Okay, fine. Hello, everyone. So this evening, we are pleased to host Dr. Aya Moheddine, who will be kicking off the security-related topics in our webinar series. Dr. Aya is a LU graduate with a PhD in telecommunication from the University of Genoa in Italy, and she has completed a postdoctoral position in INRIA, Lille, France. Her research works mainly focus on 5G attacks, including replay and jamming attacks. And recently, she developed a 5G jamming detection module integrating ML models and 5G communication. So welcome, Dr. Aya, and please, the floor is yours.
Thank you, Dr. Ihab, and thank you for attending this webinar. So today my talk will be mainly on the work that I have been carrying on the last couple of months at INRIA Lille. So the talk will be just a minute. Okay. So here what I'm going to talk about, I will give a brief introduction about what is 5G in mobile communication and what are the improvements that have been carried out for implementing some security measures compared to traditional mobile communication. And I will give a use case of the application of machine learning on developing a module for detecting specifically jamming attacks in 5G network using the data generated from that network. So let's begin. So every new generation of wireless network deliver faster speeds and more functionalities to our smartphones. For instance, the very first generation, the 1G, brought us the very first cell phone that we were using before in the early 80s, almost. The 2G let us text for the first time, so we started exchanging messages. And the 3G brought us online. So we started using mobile, using mobile data or internet on our mobile phones. And 4G delivered the speeds that we have been enjoying the last 10 years. But as more users come online, 4G networks just reach the limit of what they are capable of, where at a time where users want even more for their devices and smartphones. So here comes the fifth generation or the 5G of wireless communication networks, which is able to handle 1,000 times more traffic than the traditional 4G networks, and it is up to 10 times faster than the 4G technology, making it the foundation of different applications such as autonomous vehicles, virtual reality, and massive IoT. So what is 5G? 5G is a combination of different new technologies, which are mainly millimeter wave, small cells, and MIMO. So we'll start with the millimeter wave. And millimeter wave, why it was introduced for 5G? Our smartphones or our devices use very specific frequencies from the radio frequency spectrum, which are typically under the 6 gigahertz. But these frequencies started to get more crowded as carriers can only squeeze a limited number of bits of data on the same amount of the frequency spectrum. And as more devices are coming online, and we can start to see some slower services and more dropped connections. So the solution was to open some new room. So here comes the concept of the millimeter wave. The new room that was introduced by the millimeter wave typically fall between the 30 and the 300 gigahertz, where the section of the spectrum has never been used before for mobile communications, which means more bandwidth for the user and for everyone. But millimeter wave has its own drawback. So there is a problem with millimeter wave, which is solved by another technology which was introduced by the 5G. Millimeter waves cannot travel through buildings or any other obstacles, such as cars or trees. So to overcome this problem, the small cell technology is introduced. As we can see here, And traditional wireless networks, which are mobile communication networks, rely on the large, high-powered cell towers to broadcast their signals over long distances. But when we are using the higher frequency millimeter wave, it has harder time to travel over the obstacles. So when you are having your mobile phone and you move behind a building or behind a tree using the millimeter wave, you will lose your signal. So small cell networks come to the action with the 5G networks in order to solve the problem of the millimeter wave. So using thousands of low power mini base stations, these base stations would be much closer together than the traditional cell towers, forming a sort of a relay team in order to transmit signals around the obstacles, which is considered to be a very useful technology in crowded cities. The third technology that came with the 5G is the MIMO, or the multiple input, multiple output. In 4G base station, there exist about dozen ports of antennas, as can be seen in this figure, if we can say. These antennas will handle all the cellular traffic. But when the MIMO is introduced, we have 100 ports of antennas, which could increase the capacity of today's network. So these are the three new technologies that came with the 5G. So what is the network architecture of 5G? Similar to the traditional mobile communication networks, it is mainly formed of composed of three parts. The user equipment part, which is our cell phone, for example, or IoT device, if we can say. The RAN, or the radio access network, or in 5G it's known as the G node B, or the next generation node B. This 5G base station is composed of central unit, which handles the higher layer protocols, the distributed unit, which process the baseband signals, and the radio unit, which manages the radio transmission and reception. And finally, we have the 5G core network, which is considered as the brain of the 5G network, and is formed, as you can see, of these blue blocks, different services of the and functionalities of the 5G network, which are softwareized and virtualized. These functions handle and manages the connections, the security, and the data routing within the 5G network. Why security in 5G is a big deal? 5G is not just about having faster video or smoother video calls or faster video streaming on Netflix or whatever. It becomes the backbone for things we rely on every day. Thus, the security is considered as a big deal in 5G network. For instance, the 5G communication or technology is designed to support mission-critical applications, such as the autonomous vehicles and some healthcare systems, where security breaches could have some life-threatening consequences. So 5G, okay, it powers our phones, it powers our cars and cities and critical infrastructure, but any breach is not just a minor thing. It must be taken into consideration because it can interrupt essential services and compromise safety and invade privacy. So, to ensure the security in the 5G networks, several measures have been implemented compared to 4G, which are as improved version of the 4G. For example, this table gives a summary of some of the security features that have been implemented in the 5G technology. If we can say, the encryption in 4G was based on the 128-bit encryption keys for securing the data. But in 5G, a stronger 256-bit algorithm is being used, which make the network more resistant to what is called brute force decryption attempts, in order not to decrypt the keys that are used in the communication between the user equipment and the core network, which because that will have to demand more computing powers if an attacker wanted or attempted to break that keys. A second improvement compared to 4G is in 4G networks, the operators used the temporary identifier, which is known as the TIMC, in order to avoid transmitting the permanent identifier for each user in plain text. However, in certain scenarios, it was transmitted in clear text between the user and the core network for the 4G, which make it vulnerable to what is called MC catcher, which allows the tracking of the user without his knowledge. While in 5G, another identifier is used, which is known as the SUPI subscription or the subscription permanent identifier. But this identifier is never transmitted in clear text. Instead, the SUPI or the subscriber concealed identifier is used in the 5G, which prevents the unauthorized tracking of a user identity. And finally, in 4G, the control plane or the part of the network that is responsible for the signaling process in the network was integrity protected against any tampering over the air, whereas in 5G not only that part of the network is being secured, but also the data plane, or what is known as the user plane in the 5G network, which is responsible for routing the data transmitted from the user to the core network, is also been integrity protected, which prevents the attacker from modifying the actual content of the message that has been transmitted. Okay. So far, I just gave a brief introduction about the 5G technology, its component or its network architecture, and the security measures that are implemented. Because till now, we still having the 5G network that is relying almost 50% on the 4G core network and not the 5G. In some countries, such as the US, I think it's fully 5G networks, which is known as a standalone. In Europe also, but in the Middle East, I think it's still in the non-standalone phase, which means that only the speed of the 5G, but the core network of the 4G, which is known as non-standalone 5G networks. Okay. So we have introduced the 5G network. What is the 5G technology, its components, and the security, which make it more secured compared to the previous traditional generations. But these measures don't stop someone from emitting or blasting the radio frequencies with noise, because as we can see that 5G is a wireless communication, so it rely on radio waves, and radio waves are still for this moment vulnerable to jamming attacks. In the next slides, we will see exactly how to implement, or what is a power-based jammer, and the effect of the radio and its effect on the radio signals, and how to detect it from the data generated from the 5G network. But before entering into details about the power-based jammer, what is a jammer? A jammer is a device that emits signals that has the ability to transmit noise signals on a specific frequency, with the aim to disrupt the communication between the two ends of the network, between the user and the core network, or weaken the strength of the communication link, which will introduce some delay and latency in the service. In the literature, there exist three main types of jamming. The constant jammer, as its name suggests, it emits constantly the jamming signal in order to disrupt completely the communication. It's very, if we can say, it's very easy to detect because it terminate and disrupt completely the communication. The random jammer, which alternates between the periods of activity of the jammer and inactivity. For example, it emits a jamming signal, for example, for 2 seconds and then go to sleep for another 2 seconds and so on. The reactive jammer, it's known as the most power efficient jammer because it remains passive until they detect interference, until it detects some signal in the environment. Once the signal is detected, they will immediately transmit the interference in order to disrupt the ongoing communication. For how to implement a jammer, just to make it clear, the jammer must be implemented in a, if we can say, in a research environment, and I am not responsible if you try to implement a jammer and you get arrested because it is an illegal action. In order to get started with implementing a jammer, you need something which is called a software-defined radio board, or simply the SDR, which is a programmable board where radio functions such as transmitting a signal, receiving a signal, and processing a signal can be done without using any additional hardware or traditional hardware, using software only. We have in the figure, we have two examples of an SDR. We have what is called a half duplex SDR, which is equipped with only one antenna, such as the HAC RF one, which works only, for example, it transmits signals or receives signal, but not the two at the same time. Another type is the Blade RF, which is full duplex SDR board, which can transmit and receive at the same time. And we have another one, which is not included in the presentation. It's a more sophisticated one. It's called the UHD, or the ITIS UHD SDR boards. And you need an GNU Radio Companion software, which is a software that is based on Linux PC. You need a Linux operating system PC in order to start playing with the GNU Radio. It's a somehow simple software that uses a graphical interface to drag and drop some blocks of the signal processing thing. And the computation behind these blocks are all based on Python. So our developed jammer is a power-based jammer, where the jammer generates the jamming signals with varying power based on some parameters that can be given in real time. This jammer has a direct impact on the 5G network that we have if its generated power is very high, which is higher from the 5G signal power, so it's able to cause a permanent disruption and a permanent disconnection of the user equipment from the network. It also can have power which is weaker and can cause some delay in the communication, or it can have no impact at all when its power is very weak compared to the 5G signal. That means that it's a little bit hard to be detected because it's always changing its power during in real time. So in this figure, I just gave the how we build that jammer. And the first in the middle row here, this is the blade that is just listening to the environment, the 5G environment that we implemented. The second row is the noise that we generated and give it to the blade, to the transmit antenna of the blade, in order to emit that signal. So to implement everything regarding the 5G network and regarding the jammer, we have an in-lab 5G environment which is based on different components. The Open 5G core network, which is the brain of the 5G network. It's an open source implementation of the 5G core network, which handles the high-level logic, the device registration, the resource allocation, and the data routing. The SRS RAN G-Node B is the software-based base station instead of having a tower for the 5G base station. It runs on a Linux-based PC, which is connected also to the Blade RF, because we are using here two Blade RFs, as we can see in the figure. The first blade is used for the emitting the 5G signals, and the second blade is used for emitting the jamming signals. And we used also a real mobile phone which is based on Android, and this mobile phone was equipped with test programmable SIM cards in order to give it all the keys for the user equipment to be able to connect to the network. As we said before, the aim of this jammer is to be integrated with machine learning in order to be detected in, if we can say, in real time, but not for this time, until this work has been done. This module that is able to detect this type of jamming within the network in order to take required actions in the future in order to discard this affected device and reallocate the resources. This part of the work is or this is small part of the work is part of a bigger work, which is a project still not finished, called Amalsi Subs, where we were in charge of implementing an attack against 5G networks and having some sort of detection in order to discard the affected devices and reallocate the resources between the devices that are still not affected in the network. So to build our detection module, we started first with the data collection in order to build our dataset. The data collection process was conducted or was built through conducting several experiments under both the normal scenario and the jamming scenario. The data was analyzed in order to understand the impact of the jammer on the network's behavior and then extract the relevant features. Our study considered the impact of the jammer on both ends of the network, on the core network, if we can say, and on the user equipment part, the two ends of the network. So my part was considering the part of the G-Node B traces, which are more onto the core network of the 5G, which contained very rich information, such as the signal power, the throughput of the communication, the packet transmission metrics, such as the physical uplink shared channel and physical uplink control channel, signal to noise ratio, the bit rates, the packet success and failure counts, etc. So we initially also referenced our dataset regarding the G-Node B within an existing dataset that was developed by other researchers, which offers a comprehensive set of features for analyzing the network performance in both normal and attack scenarios. However, when we consider the same features as that data set, we have the complexity of that data set and the wide range of the features introduce some excessive noise to our module or to our detection of so we enhanced our scenario performance and refined our data set by selecting some relevant or subset of the features which are more relevant to the jamming attack, because that data set considered different types of attacks and not only the jamming attack. Our data set that was considered, for example, for the G-Node B traces was composed of around 6,800 entries, 900 entries, sorry, and for the user equipment as well, the same size of the data set, and it was a labeled data set which is balanced for normal and jammed conditions. The machine learning models that were considered were some were SVM, KNN, gradient boosting, and random forest. The choice of these machine learnings were based on what has been present in the literature in order to compare our module with the other jamming detection module, but not the power-based jammer, the classical jammer that already talked about the constant, the random, and the reactive. So we chose also the machine learning and not the sophisticated detection models such as deep learning models, because our dataset size is not very big. And also the literature also considered the machine learning for detecting jammer, because also this module will be implemented on some low power devices, low power edge devices, in order to detect the jamming in real time. It is considered to be implemented, I think, on Raspberry or a NUC. I'm not sure which one of these two edge devices. Then each model was tuned via hyperparameter search and evaluated with cross-validation in order to find the best settings before moving into other models in the future. So what we have obtained, we trained our 4 classifiers: SVM, KNN, random forest, and gradient boosting, using grid search and tenfold cross-validation to tune our hyperparameters. And then what we obtained is that these 4 models converge successfully and reach roughly about 90% of test accuracy. But their performance a little bit varied between the user equipment dataset and the GNodeB dataset. But we didn't stop here. To validate better our module, we took the top performing models, saved them, and evaluated them on a brand new recordings from a new experiment. So we created a new dataset and with almost the same environmental conditions. And as expected, most of the algorithms, we saw that their performance slide in terms of accuracy and other metrics, because the new data, we can say, didn't match exactly what the model was trained on. The signal shape changed a little bit, and we can say that we have a little bit extra background noise. However, on the other hand, the tree-based classifiers such as the random forest and the gradient boosting showed far smaller drops. We can say that their hierarchical and nonlinear splits make them naturally more robust to feature distribution changes and outliers, so they can adapt in a better way when we have some environment drifts. So to sum up, 5G is more secure than ever technology from the network perspective or from the network level, but still from the physical layer perspective is still vulnerable, because I think that the jamming attack is the only attack that it's not solved till now. Because as Dr. Ihab introduced, I was able to perform some sort of a replay attack before on a 5G network. But this replay attack, I think it was solved just last March, because the institution that is responsible for standardizing the protocol, the 5G protocol, which is called the 3GPP, has released its very latest security specification. Its number is 33.501 specification regarding the security features in 5G, where it obliged the operators to implement a sort of protocol, a sort of security measure called the IPsec, which prevents an attacker to implement a fake base station, or what is known in the security domain as a rogue GNodeB or a rogue base station. I was able, before introducing the IPsec thing, to have this base station implemented, where the attacker is just took the very first message that the legitimate base station can transmit to the core network, take it, save it, and replay it or re-inject it in the network, and then he has his own base station. Through this base station, the attacker can create a message, any kind of messages, and can transmit that message to the core network, which will be treated as a legitimate one because the attacker has already all the IDs that are transmitted in plain text before agreeing on the security or the keys. And I was able, for example, to create a user disconnection message using the IDs, the legitimate IDs of the user, the legitimate IDs of the base station and the core network. And I was able to disconnect a user without his knowledge, and it was treated as a legitimate message from the perspective of the core network. But this vulnerability has been solved in the latest, as I said before, with the latest 3GPP specification, which is still not in the implementation phase. It's still okay. They say that it must be implemented, but I don't know if the operators has implemented it or not, because in 5G it's different from 4G because the operator has to decide to implement it or not, because implementing it will introduce some extra fees and some extra latency in the service. So regarding jamming, it's still not a solved attack, because wireless networks are vulnerable to jamming attacks. But maybe if we considered, for example, to introduce a technology such as frequency hopping, which oblige the 5G to change its or to hop between the channels of the frequency in order to avoid such kind of attacks, or pairing some radio frequency defenses with some adaptive machine learning, maybe we can close the gap of having such attack, and we have a very secured 5G network. Thank you.
Thanks, Dr. Aya, for the amazing presentation. So we'll go for questions if there are any question. I have one question maybe, but I will stay for the last. Okay, Mr. Hassan Shamsuddin, go ahead, please.
Yeah, hello. Aya, thanks for the presentation.
Hi.
And hello all. I have just a short question, might not be related directly, but I was like inspired from the idea of jamming or jammers. I remember like years ago in the university, I mean, 5 years ago in the university, when I was taking the lecture of 5G, the prof back then mentioned about 6G and that it will be presented somehow in the 2030s. Do you think, or is there any researches, reports about 6G being not vulnerable for the jamming stuff or the hopping, the frequency hopping, as you mentioned?
I have no idea and no knowledge about 6G, but it's easy to say that it would be implemented, as I said, because 3GPP specification, okay, say mention it in their specification, okay, we need to implement this and this and this, but are the operators going to implement that or not? We are still in the implementation phase of the 5G. Still till now, 2025, we still are using the core network of the 4G and not the 5G. So it's a very long discussion. We can say that no one can guarantee that in 6G it will be solved or not. We need to wait and see.
Thanks a lot.
You're welcome.
Thanks. So I'm not sure if the person who are asking is a doctor or a master. So I will say master for everyone, huh? Master or Mrs. Fine. Another question, maybe Akram, Mr. Akram. Fine. I will ask my question, Dr.
Yeah,
Aya,
sure.
if you please. Okay, it's not a question, it's just a remark, in fact. So what are you trying to do is to build a detector for jamming. But you know, now in the world of AI, there is a trend which is explainability.
Yeah.
So what we are trying to do is to explain how the model acting. So like that, the bad guy, let me say, that can also detect or explain the behavior of your model, so that he can make the variation or the necessary variation to make your model unable to detect jamming. You know, you know what I mean? So you see what I mean? So because
you mean the behavior of the jammer or the model? Because
of the model. No.
Okay.
I am the bad guy. I am the one who has built the jammer. I know you have somewhere a model to detect if I'm sending I'm doing jamming or not. So what I can do, I can detect the behavior of your model.
Okay.
So in which features the model give importance in order to detect if this is a jam or not. So like something like this. So we call this a counterfactual explanation. So in this case, I can make the necessary variation in my signal to stay jammer as a jammer, to stay noise.
But
However,
not detected as jammer.
Yes, exactly. But
it could be.
Yes.
I'm not expert in explainability. I'm more expert in communication and networking stuff. And actually, this was my very first use case to use machine learning. I know machine learning theoretically, but it was my very first application, hands-on application with machine learning on such kind of data. But it could be a beginner point in order to go with that research. But unfortunately, I'm not a part of this project anymore as my contracts end. So maybe I can forward your question to my PhD student who is still working on this. I can consider that. Yeah.
Okay, great. Thank you.
Welcome.
Okay. Do we have more questions? Fine. Okay, Dr. Aya. So thanks for the amazing presentation again. It was really interesting. And thanks everyone for being here. See you next week.
Thank you.
Sorry. There is questions. Oh, there is questions. Sorry. Yes. Muhammad Rahal, Ibrahim, Dr. Ibrahim. Okay. So we have time. Muhammad, go ahead, please. Muhammad is an engineer in telecommunications. So
yeah.
Okay, Dr. Ihab. Thank you, Aya, for great presentation.
Thank you.
I have only one question.
Yeah, sure.
The simulation in this project, mainly you made this simulation in the physical layer, since you